So in this video, we're going to take a look at how to transform functions again, but this time we'll be looking at reflections specifically. So again, let's start off with our function, and we'll keep a nice, easy, straightforward start. We'll define again f of x to be x squared, and you can see the graph of x squared. Look there, it is that nice parabola shape with a minimum point at 0, 0. So what would happen then if we replaced our x with, let's our f of x with, let's just put a minus sign in front of it. What is that going to look like algebraically? And of course, the main point of this video, what's that going to look like as on a graph? So algebraically, it's dead easy. We're just going to put a minus sign there, look, okay? But what is going to happen to the graph? Now, keep your eyes on the shape of that graph. Now, if I want to put the minus sign in, there you go. It's flipped, hasn't it, right? Okay. In fact, what's happened there is that it has reflected in that x-axis. So we can say if we put this minus sign in front, it's a reflection in the x-axis. Now, does that work with any function? Well, let's just go back a second and let's start off and redefine a new function. Maybe we could start with x cubed, right? So x cubed is there. So if we put a minus sign in front of this, does that reflect it in the x-axis? Keep your eyes on the diagram. So putting that minus sign in, yep, that works, doesn't it? Right, okay, let's put it back. Okay, so this really does work. It's not just when we define it to be x squared, it's going to work with any function at all. We just put that minus sign in front. Okay, next thing, well, let's go back to the x squared graph again as our basic function. Now, this time, I would like us to think about x squared, and let's, instead of putting that minus sign on the outside, first of all, again, we'll define f of x to be x squared. Let's imagine we, instead of acting f on x, we act f on minus x. So what's going to happen algebraically? What's going to happen graphically? I think this time I'm going to start with the graph itself. So what do you think is going to happen? Let's put that minus sign in replace of the x. Well, it looks like not a lot has happened. Let's go to the algebraic version, see what's happened there. So if I'm acting on minus x, I'm doing minus x squared. But you know what? When I do minus times a minus, so minus x times minus x, of course, it means it's positive. So nothing's really happening there. We can't see any relationship. Let's just go back then and try and do this same thing on x cubed, right? Maybe let's say, well, rather than using an f, let's just do a g, right? So g of x is equal to x cubed. Then consider what is going to happen to g of minus x. Okay, so let's go back. Let's get rid of the minus sign. Let's swap this out to be a cube. So there's our cubic function. So this time, what do you think is going to happen when we put the minus sign in? It's reflected again, right? Okay, but it hasn't reflected in the x-axis. What's happened is it's reflected in the y-axis. There you go, look, okay? So when we put a number, a negative sign inside there, we act on the negative rather than the positive, okay? This is a reflection in the y-axis. Now, going back to the x squared graph, why do you think that nothing happened, or it appeared not to happen anyway, when we swapped it out? Well, of course, it's because it's already symmetrical about that y-axis. So if I flipped it on the y-axis, it would look absolutely the same. So despite that, though, it's really important we remember that when we put that negative symbol there, look, okay, we reflect in the y-axis. So when it's inside the bracket and we act on a negative, it's the y-axis. When we put that outside, like minus, like that, then that would be a reflection in the x-axis. Okay, hopefully you've understood this video and you can answer the questions on this particular feature of transformations.